All right, good morning everybody. Today we're going to talk about solving exponential functions. Not very difficult. Part of it's very easy. The other part is just a little tougher. The important thing is that you know your squares. So we're going to talk about some squares today that you should know, and even some cubes that you should know, kind of in the back of your head to make this easier for you. So first of all, when solving exponential equations, we're able to set the exponents equal to each other if we have the same base. So what does that mean? That means basically this. If I have here a base of 2 to the 3x, and I have here a base of 2 to the 6th, if I have the same base, basically we can just cross those out and set these top things equal to each other. So 3x equals 6, so x, when we divide both sides by 3, x must equal 2. So a lot of it is that easy. It all depends on us being able to get the same base on both sides of the equal sign. Then we can just set the exponents equal to one another. And today, in order to do that, we must familiarize ourselves with some of the basic bases and exponents. And as I said a minute ago, these are going to be very good for you to learn. So let me write some of these down, the ones that I think are important for you. You should write these down on a separate sheet of paper as well. So pause the video, get yourself out a sheet of paper and write these down. Alright, 2 squared. 2 squared, 2 times 2, 4. 3 squared, 3 times 3, 9. 4 squared, 4 times 4, 16. 5 squared, 5 times 5, 25. 6 squared, 6 times 6, 36. Again, I'm writing these down because these are the ones that you should know off the top of your head to make this work easier for you. If you don't know these off the top of your head, you should probably make flashcards so you can learn these. 7 squared, 7 times 7, 49. 8 squared, 8 times 8, 64. 9 squared, 9 times 9, 81. 10 squared, 10 times 10, 100. 11 squared, 11 times 11 is 121. 12 squared, 12 times 12 is, you know this one, right? 144. Next one, 13 squared, 13 times 13, 169. Next one, 14 squared, 14 times 14, 196. 15 squared, 15 times 50, 15 times 15, I should say, 225. And last one, 20 squared, 20 times 20 is 400. If you know all of these, it is much easier and quicker to work these problems. All right, some more things I think are helpful knowing that you can make flashcards from if you don't have any. Oops, they go through all this. We just did that. Looks like we got the right answers. All right, more exponents. The cubes. 2 to the third is 8. 3 to the third is 27. Again, you should be writing these down on a separate sheet of paper. 4 to the third is 64. 5 to the third is 125. 6 to the third is 216. 7 to the third is 343. All important to know. And then just a couple of fourths that are good to know. 2 to the fourth power is 16. 3 to the fourth power is 81. And 4 to the fourth power is 256. Now again, you can use your calculator to do some of this, to kind of back around, take square roots, take cube roots. Much faster process, much easier process if you already have these in your head and able to use. Alright, let's go solve some things. Let's skip those. Those aren't important over there. Alright, so here we go. 2 to the x plus 5 power equals 2 to the 8th power. What did I tell you a minute ago? If you have the same base, you can cancel those bases out and set the exponents equal to each other. X plus 5 equals 8. Subtract 5 from both sides. X equals 3. Done. It's just that easy. It's just that easy. Let's skip down to problem number 3. There is problem number 3. Make sure we remember how to solve these basic equations. 3 to the something equals 3 to the something. The 3's cancel out. X minus 5 equals 2 times x plus 7. And you think to yourself, what's the first thing I do here? Hopefully you say distribute. So we're going to distribute on the right hand side. So x minus 5 equals 2 times x is 2x plus 2 times 7 is 14. Now we have what we need to go ahead and solve. I'm going to subtract x from both sides. Give me negative 5 equals 2x minus x is 1x plus 14. Final step, I'm going to subtract 14 from both sides. And I get negative 19 equals x. So again, should be pretty easy if the exponents are equal to each other. Let's pop down to problem number 6, which is our first one that we see that the exponents are not equal to each other. But I want to get them equal to each other. So what I do is I look at my lowest exponent, which is a 3, and I say, can I get my bigger exponent in terms of my little exponent? So what I'm saying is that, is 9 a power of 3? Yeah, 9 is simply 3 squared. So I can rewrite 9 as 3 squared, but then I still have my x plus 7 up here. X plus 7 equals 3 to the x minus 5. So see what I've done? I've rewritten 9 as 3 squared. I still have my x plus 7, so I have to put it there. But now I see, well, wonderful, I've got 3's. Cancel, cancel. X minus 5 equals 2 times x plus 7. Now the problem looks just like the last one that we did. We're going to distribute on the right hand side first. X minus 5 equals 2x plus 14. Wait, didn't I just do a problem almost exactly like this? First step, subtract x from both sides. Negative 5 equals x plus 14. I think I did. Subtract 14 from both sides. Negative 19 equals x. Yep. So it worked out the same. So again, we started with different bases, and I changed this base to match this base. So you're looking to change the bigger base into the smaller base. Let's look at problem number 7. All right, how can I change 4 into a base of 2? That's right, 4 is just 2 squared. So I have 2 squared, I still have my 3x up there, equals 2 to the x plus 10. Common bases, cancel out the bases, and I have 2 times 3x equals x plus 10. Multiply, 6x equals x plus 10. Subtract x from both sides. 5x equals positive 10. Divide both sides by 5. X equals 2. Easy peasy? I hope so. I hope this is pretty easy for you. Alright, now, that's almost the most complicated we can do. The most complicated that we can do look like numbers 8 and 9. So let's go look at 8 and 9. There it is. So, if we did it like we've been doing it, I would think, okay, 4 is my small one. How can I get 8 in terms of 4. Well, is 8 a power of 4? No, it's a multiple of 4. 2 times 4 is 8, but 8 is not 4 squared. So 8 is not a power of 4, so I can't do it that way. But I look and I say, is there anything they have in common? Do they have a base in common? The answer is yes. Isn't 4 2 squared? And isn't 8 2 to the third power? Sure, 2 times 2 is 4. 2 times 2 times 2 is 8. There I have my common base. Write the exponents that were included. There's a 3x. There is an x plus 1. So great, now I've got a common base. Cancel, cancel. 2 times 3x is 6x equals, distribute. 3 times x is 3x. 3 times 1 is plus 3. Easy solve, I think. Take 3x away from both sides. 6x minus 3x is 3x equals 3. Oh, almost done. Divide both sides by 3. X equals 1. Great. Let's do one final one. Let's do problem number 9. There I am. Okay. So I look again. I look at this small base, and that's a 9. This is a 27. Is 27 a power of 9? No. 9 squared is 81. Now 27 is a multiple of 9. 9 times 3. But that doesn't help us there. So we got to think, what bases do they have in common? If you thought 3, you were correct. Isn't 9 3 squared? And isn't 27 3 to the third power? So you see where knowing your bases and exponents, what they equal to, can be very handy here. Because if you knew that 3 to the third power was 27, you would get it much quicker than hunting around for it. So on this one, I still had my 3x minus 5. On this one, I still had my 3x plus 2. Cancel those 3's out. And now distribute. 2 times 3x is 6x. 2 times negative 5 is negative 10. Equals 3 times 3x is 9x. 3 times 2 is 6. Alright, well, let's do a solve here. Let's subtract 6x from here and 6x from here. Remember, there's several ways you can solve this. I just look to always get positive numbers for my x's. Alright, subtract. Gives me negative 10 equals 3x plus 6. Negative 10 equals 3x plus 6. Subtract 6 from both sides. Negative 16 equals 3x. Divide both sides by 3. Negative 16 over 3 equals x. So x equals negative 16 over 3. Let me check my work there. 6 minus 10. 9 plus 6. Subtracted 6, I got 3. Subtracted 6, I got negative 16. Yep, looks right. X equals negative 16 over 3. Alright, so hopefully you see how this is working. Please finish the few that we didn't do on this front side, then turn to the back side and complete 10 through 21 on the back after you do that. If you have questions, come up and ask as you're working through this. If you need to watch this again, feel free. That's why it's here. Alright, thank you.